continuing on. So previously we answered this problem. We're answering the next. We're still on propagation of error. That is under that's one of the applications of differentials. So for our next scenario, we have this cylinder, and if you look at the circle itself from the top, let me draw a better circle. So apparently we are given the height of the cylinder, which is 1.6 meters, and we are also given a diameter, which is said to be 2.5 meters, and we have an error in the diameter, which is 50 millimeters. We can convert this in meters, so that's going to be 0.050 meters, and we could rewrite this as a fraction. We'll write that as 50 over 1000 meters. So what else? So that's it. What are we supposed to find? We're supposed to find the internal volume of the cylinder. So since we have a thickness, there is an outer volume and an inner volume. So the inner volume is basically going to be equal to the volume minus dV. Since we have the diameter, we can derive from that the radius, and using the height and the radius, both of them are found in the formula of a cylinder, pi r squared h. And we could use pi r squared h to find, well, the outer volume. And the dV is basically going to be the total volume of the thickness, which is 50 millimeters. It's consistent. So this is going to be our dr, and our dh is going to be also, so if you imagine supposedly, so this is what the cylinder looks like uh, from a side's point of view. So the thickness we have from the bottom and from the top. Although I don't think this is going to be relevant, since we are only dealing with propagation of error. You will need this if you solve this kind of question using another method. I just don't remember the name right now, but basically that's a more efficient method. But again, it's basically locked yet as of now. You have to know this first. So with that in mind, in that case, we'll have to express either in terms of r or in terms of h. So it's either volume and radius or volume and height. So how do we do that? So we have 2.5 is our diameter, right? So the radius is going to be 2.5 over 2, or basically 25 over 20. Simplify that further, you have 5 over 4. So 5 over 4 radius over the height, which is 1.6, 16 over 10, 8 over 5. So we have radius over height. 5 over 4h equal to 8 over 5r. 5h is equal to 32 over 5v. Sorry, this is not v, this is r, radius. So 32 over 5r, divide both sides by 5, you'll have 25. So you could use this. Let's see. R is equal to 2H. Is that true? Hmm. Anyways, um, so we have pi r squared, and then h is going to be 32 over 25r. So that can be also equal to 32 pi over 25r cubed. That is our volume. We could actually look for the volume already. R is equal to 5 over 4 raised to 3 from each. So 32 pi over 25. 5 raised to 3 is 125. 4 raised to 3, 16, 64. If we simplify, 5, 2. 5 pi over 2. Are we on the right tracks? Can we simplify this? 5 over 4, 5 over 8. 25 over 32. I don't get why my solution is different from the answer keys. Maybe, no. Looking for the volume, we have both the radius and the height, so I don't get why I decided to do that. Pi r is 5 over 4 squared. Height is 16 over 10, 8 over 5. 25 over 16 times 8 over 5. 5, 2. Huh. No. 16 over 10, right? 1.6 could be rewritten as 16 over 10. Huh. The answer key didn't put a square. So, damn. I guess my answer is wrong. I think we are in the right tracks. Uh, so 5 pi over 2, that is our volume. And then our dV is coming from pi r squared h. This is where we substitute. So r squared and then h is 32 over 25 r. Now when we simplify, we're gonna have 32 pi over 25 r cubed. R is what? It's 5 over 4. 125 over 64. In other words, cancel. 5, 2. What information? Oh, my bad. I forgot to differentiate. So we apply power rule. So it's gonna be 3r squared times dr. 3 pi over 25. 3 times, what's our r? 5 over 4. 5 over 4 squared times dr. dr is what? 50 over 1000. Notice all of the values we inputted are in terms of meters. It has to be as 1 unit, otherwise your solution is going to be wrong. Rewrite this as 25 over 16. 1 over 20. 9 pi 16 times 20. Are we on the right tracks? I can't guarantee. My answer key is already compromised. $3.20. So with that, the interior, or basically the internal volume, is basically going to be volume minus dV. So the theory is correct. In case my actual answer would be wrong, the approach is correct. So you'll get partial points anyways. So yeah, that's it. Next question. So we have a hemisphere, and we are said that we are told that the diameter is 8 meters, so the radius is going to be 4 meters. We are also told that the thickness of the coating, so basically this hemisphere was coated. The coating is 15 millimeters thick. So imagine in terms of donuts. So the glazing, of course, there's a thickness. So how thick is the glazing? Assume that it's consistently 15 millimeters in terms of, let's say, maybe in the context of construction, coating could be in terms of paint. So 15 millimeters. Right now, I'd like to convert this into meters. So it's going to be basically divide by 1000. So what is missing, what we have to find, is the amount of coating that was used, or in terms of dV. That is what is represented by dV, the amount of coating that is used. So first you have to know what the formula for the hemisphere is supposed to be. It's 2 over 3 pi r cubed. So with the diameter, we have the radius, therefore we can find the volume. So why do we need the volume? Actually, I don't think we do. We're looking for dV. We're not looking for percent error. We're not looking for interior volume. We're just looking for dv. So as soon as possible, find the derivative already. 2 pi over 3 times 3r squared times dr. Our dr, 15 over 1000, we can simplify this further. 3 over 200 meters. So, I believe these could cancel. 2 pi r squared, 3 over 200. 3 over 100 pi r squared. Are we on the right path, chat? Radius is 4, right? Where is our radius? 4. 16. So, we have 4 and then 25. 12 pi over 25. This is our dv. And this is the final answer. Don't forget the unit. The amount of coating that was used. Meter cube. That's it. What's next? Addendum. Implicit differentiation. Implicit differentials. Let's try a few practice problems on implicit differentials. So let's say xy plus 3x squared equal to 2y cubed. So this is differentials. So we are solving both with respect to x and y. So for example, here, product rule, derivative of x is 1. Don't forget your dx over dy, or just dx. And then just copy y, plus copy x, and then derivative of y, dy. 3 times 2x times dx. Okay, and then 6y raised to 2 times dy. dxy plus xdy plus 6x dx equal to 6y squared times dy. So in differentials, again, the format is dy equal to derivative times dx. So all dy will be at the left side. X dy minus 6y squared dy equal to negative dxy minus 6x dx. There you go. dy is equal to negative dx I think that's it. Yep. That's the final answer. How about involving 3 variables this time? So we have dz equal to 2 times This is before applying derivative. Let's transform this first into exponential form. And then we start finding the derivative. 2 times 1/2 is 1. Product rule. 1 times dx times y plus x times dy. Yeah, that's it. And then plus dx. Don't forget the sign, the radical sign. I think that's it. At this point, you just write it like that if there's a third variable. That's it for this video. I'm not going to um, have a walkthrough on the last sample problems anymore. That's it. Thanks for watching.